Equilibrium constant K expressions. How we can write K expressions in terms of concentration and pressure. Equilibrium constant K in terms of concentration, the formula is product concentration divided by reactant concentration. So let's take a hypothetical reaction. A moles of A plus B moles of B is in equilibrium with C moles of C plus D moles of D. For this chemical reactions, all four species, both reactants AB and both products CD, are in aqueous phase. So let's write Kc expression, equilibrium constant in terms of concentration. All the products in the numerator and all the reactants in the denominator. You can see molar coefficients appeared in the balanced chemical equation, that is lowercase letters, appear as exponents in the expression. Let's take Kp. Kp is equilibrium constant in terms of pressure. Kp is equal partial pressures of products divided by partial pressures of reactants. Again, let's take the same reaction, but here reactants and the products are in the gas phase. If the reactants and the products are in gas phase, then we can apply Kp. Kp is equal partial pressure of C to the power C times partial pressure of D to the power D divided by partial pressure of A to the power A times partial pressure of B power of B. Now using this Kc and Kp, let's try to solve example. Write equilibrium constant expression for Kc and Kp if applicable for the following processes. First reaction. 2 moles of methanoic acid, or another name is formic acid, is in equilibrium with formate plus H plus ions. For this reaction, you can see all three reactant and product, all three species are in aqueous phase. So we can write Kc expression. Kc is equal all the product concentration divided by reactant concentration. Products molar coefficients 1 for both formate and H plus, but formic acid molar coefficient 2 used as exponent in the expression. Second reaction, 2 moles of mercury 2 oxide is in equilibrium with 2 moles of mercury plus oxygen. So here mercury oxide is solid phase. Mercury is a liquid at room temperature. Oxygen is a gas. This is heterogeneous equilibria. For this heterogeneous equilibria, the rule of writing equilibrium constant is solid concentrations we can assume as constant, and pure liquids and solvents concentration we should not consider in the equilibrium constant expression. So solids and liquids let's ignore, and oxygen is the only species we can write in the equilibrium constant expression. Kp is equal partial pressure of oxygen. Or if you want to write in terms of Kc, Kc is equal oxygen concentration. Next, 2 moles of carbon dioxide is in equilibrium with 2 moles of carbon monoxide plus oxygen. All three species in gaseous phase. So we can write Kp or Kc. Kp is equal partial pressure of carbon monoxide exponent 2 times partial pressure of oxygen exponent 1 divided by partial pressure of carbon dioxide exponent 2. Last one, 3 moles of oxygen is in equilibrium with 2 moles of ozone. For this reaction, both oxygen and ozone in gas phase. So Kp is equal partial pressure of ozone squared divided by partial pressure of oxygen power 3. I hope now you will understand how to write the equilibrium constant expression in terms of concentration, that is Kc, and in terms of pressure Kp.